Welcome back, everyone, to the Idea Mechanics Lab. Today, we're diving into TRIZ, the theory of inventive problem solving. It's an incredible methodology that takes innovation and turns it into a highly repeatable science. As always, our lead innovation catalyst is here with us. You'll see him right there, our resident expert with the glasses, silver-accented hair, and red shirt. He's going to walk us through a really crucial explainer today. Don't ruin your production line and the devastating cost of the perfection myth. If you've been burning a fortune or trying to engineer absolute, flawless perfection on the very first try, well, you are about to see exactly why industrial agility is not about impossible precision. So let me ask you, are you chasing impossible precision? So many of us get stuck in this exhausting trial and error guessing game. We just sit around waiting for some lucky eureka moment to magically fix our workflows. But innovation, it isn't just a rare spark of genius. It's actually a highly repeatable architectural discipline. As our catalyst always reminds us, we really don't need luck to innovate. We just need a robust system.
If you're ready to stop relying on luck and start mastering systematic discovery, hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you. Drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next.
All right, let's jump straight into it. Step 1, the mindset shift.
The old trial and error way completely assumes that a high-quality process requires 100% exact, flawless precision. Because of this, we build these highly complex, fragile, and honestly super expensive systems just to deliver the perfect amount of material or time. But what happens when that perfect control fails? The whole process breaks down. The TRIZ way, however, embraces something called strategic imperfection. It systematically and intentionally overshoots or undershoots a target to achieve a highly practical, reliable outcome.
Our innovation educator is pointing to the formal definition on screen right now. This is TRIZ Principle 16, partial or excessive actions. The core idea here is incredibly powerful. If achieving a perfect, 100% optimal solution is difficult, costly, or just downright impossible, you intentionally use slightly more or slightly less of an action. Then, you simply apply a secondary action to correct that deviation. This completely simplifies your primary process, because suddenly it no longer needs to be controlled with extreme fragile precision. Let's look at how this actually plays out on the floor. Step 2, manufacturing resilience.
Think about industrial casting for a second. Trying to pour the exact perfect amount of molten material into a mold is incredibly difficult. Even a slight shortfall gives you a defective, ruined part filled with voids. So what do smart manufacturers do? They systematically apply an excessive action. First, they intentionally overfill the mold. This completely guarantees a solid defect-free part. Then, step 2, they simply cut away the excess material, often called the sprue or runner, in a later finishing step. They just do slightly more than necessary to flawlessly guarantee quality, entirely bypassing the need for expensive, hyper-precise pouring equipment.
We actually see this exact same logic in industrial coating and painting. Instead of burning through budgets trying to apply a single, perfectly measured coat of paint, which, let's be real, is nearly impossible to control, engineers use strategic excess. They utilize intentional overspray to guarantee complete surface coverage. Then, they simply smooth it out, or collect and recycle the excess paint. It is vastly easier to apply a generous amount and refine it than to attempt a perfect application in a single, fragile step.
Moving beyond hardware now. Step 3, operational buffers.
When we look at services and logistics, we simply can't control unpredictable real-world variables. Weather, traffic, sudden supply chain hiccups. Pinpoint precision is basically a fantasy here. Therefore, service industries must systematically build operational cushions. And they do this by applying excessive actions to their timelines and protocols.
To put this into perspective, think about delivery times. A company promises a customer that their delivery will arrive by 5 p.m., but their internal target is actually 3 p.m. By setting this intentionally excessive, earlier target, they create a fantastic operational buffer that easily absorbs any unexpected delays. Or, what if a customer receives a bad product? A smart company doesn't just refund the cost. No, they apply excessive positive action, a refund plus a free gift or maybe a major discount. This overcompensation does way more than just fix the issue. It systematically turns an angry customer into a fiercely loyal advocate.
Now let's scale this up to the macro level. Step 4, environmental management.
When managing agriculture in arid regions, deploying highly complex, fragile irrigation systems that deliver the exact, precise drop of water to each plant is incredibly expensive and prone to failure. So instead, agricultural engineers use controlled excess. They intentionally overwater the plants. This successive action guarantees deep root penetration, completely compensating for unpredictable evaporation and surface runoff. It's a practical, robust, and highly effective solution.
And as our catalyst loves to point out, one of the most powerful applications of this principle is in forest management. You absolutely cannot precision clean an entire forest. So experts conduct controlled burns. They intentionally design these fires to be slightly more intense than what might seem strictly necessary. This controlled, excessive fire guarantees that all the dangerous flammable underbrush is entirely consumed. By intentionally overshooting the target just a bit, they systematically neutralize the risk of future catastrophic wildfires.
Which brings us to our final takeaway today. Engineer your strategic excess.
It's really time we stop building fragile, overly complex systems that just break the moment a variable shifts. By aggressively applying TRIZ Principle 16, you can start engineering resilient, simplified processes. Intentionally overshoot your target, guarantee the outcome, and then just easily trim the excess. It is a highly repeatable skill, and it guarantees flawless execution out in the messy, real world.
So, I want to leave you with this provocative question today. Look at your own production lines, your software deployments, your team's workflows. Where are you burning money and time chasing impossible, 100% perfect precision? And more importantly, how can you apply Principle 16 today to engineer your own strategic excess and simplify your entire process? Think about it. Let's start building that culture of systematic innovation together. Catch you in the next one.